Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for previous NEET questions from the chapter Electric Field and Charges. This is 12th class chapter. Let us continue. First question is, two identical charged spheres suspended from a common point by two massless strings of length L are initially at a distance D. Instead of D, you consider X apart because of their mutual repulsion. The charges begin to leave from both the spheres at a constant rate. As a result, the spheres approach each other with a velocity v. Then v varies as a function of the distance x. So therefore, as already I told you, make distance d as x between the spheres as. So therefore, you understand the question with the help of diagram. So this is the rigid support. So this is the first string. Yeah. So there is a sphere here. The sphere here. This is second string which is also connected to the sphere. So initially they repel with electrostatic force. You can take other side also. There is mg here. Now tension acts towards point of suspension. The component of tension. So taking tension into two components, t cos theta. When theta is taken here, then the other component t sin theta balances the electrostatic force. So let us write free body diagram. Fe, electrostatic force, 1 by 4 pi epsilon naught q square by x square is equal to t sin theta. Call this equation 1. Similarly, t cos theta is equal to mg. So call this equation 2. Divide 1 and 2. So if you divide 1 and 2, you'll get sin tan theta is equal to 1 by 4 pi epsilon naught q square and d square x square get multiplied with mg. Suppose if after leakage the spheres are coming towards each other, so therefore they will be at a distance of d by 2 or x by 2 finally. Therefore theta minimum, so this value decreases, L will continue. Therefore there is a provision in trigonometry in case theta reducing. So tan theta can be replaced with sin theta with 1 by 4 by epsilon naught q square by x q square mg. So this sin theta can be, now theta is sin theta is opposite by hypotenuse, that will be x by 2 with divide by L means you can multiply L with the 2. So this is going to be 1 by 4 by epsilon naught q square by x square with mg. Now, so this is going to be mg and L 4 pi epsilon naught all are constants. You can directly write q square proportional to x cube. So otherwise q proportional to x to the power of 3 by 2. So therefore, so now you differentiate dq by dt proportional to. So differentiation of this first, n into x to the power of n minus 1. So now n is 3 by 2. So now this is going to be x to the power of 3 by 2 minus 1. Otherwise you can write root x dx by dt. So dx by dt is velocity now. So therefore you can write dq by dt is proportional to 3 by 2 with root x and velocity. So now velocity and root x are inversely proportional. Velocity and root x, because these two are in multiplication. So therefore inversely proportional means you can write like this. Otherwise v proportional to x to the power of minus 1 by 2. So first you write this is x to the power of 1 by 2 and take it up minus 1 by 2. So first option is correct. This is given in 2016. Moving to the next question. Question number 2. This is also given 2016 but phase 2. Electric dipole is placed at an angle 30 with the electric field intensity 2 into 10 to the power of 5 Newton per Coulomb. It experiences a torque equal to 4 Newton meter. Finding the charge when dipole length is 2 centimeters given. So get back directly formula instead of writing data and all. Torque is equal to dipole moment, electric field intensity with sin theta. So theta is the angle between dipole moment and electric field. So there is separately you have to write 2L with the charge with E sin theta. Next, so 2L is mentioned 2 centimeters, make it into meters, 10 to the power of -2. Charge we are looking for. Intensity of electric field is given 2 into 10 to the power of 5. Yeah, so sin 30 is 1/2. Other side you have torque value, that is 4. Therefore, this 2 and 2 get cancelled. Then there is one more cancellation. This is also 2 2s of 4. Therefore, finally you'll get there is one more. This is minus. This is +5. This is -2. So there will be 3. So you are left with 2 into 10 to the power of -3 is equal to Q. So taking this 3 down, so it will be -3 coulomb. So therefore, otherwise 2 millicoulomb. So 1 milli is 10 to the power of minus. So second option is correct. Moving to the question number 3. Suppose the charge of a proton and electron differ slightly. One of them is -E and the other is E plus delta E. If the net electrostatic force and gravitational force between two hydrogen atoms placed at a distance d apart is 0, then delta E is of the order of. So let us try to write electrostatic force first. Before that, let us find total charge. Charge on proton and charge on electron. So this is the difference. Delta E is the difference. So let us say proton charge is delta E plus E. Electron charge is -E. This is the difference. So delta E. Now let us try to find out electrostatic force first. It is 1/4 pi epsilon naught delta E square by d square. So we'll get this is 9 into 10 to the power of 9. Charge of electron. So it's 1.6 into 10 to the power of -19 multiplied with 1.6 into 10 to the power of -19 divided by d square. So if you simplify this, so this is 9 into 2.56 because 60 is the 256. So since there are points, 2.56, then this is going to be -10. So this is -10 -19 -29 by d square. So this is electrostatic force part. Now moving to gravitational force part. So G, capital G, mass of hydrogen and mass of hydrogens divided because two hydrogen atoms given by d square. So get back the value of gravitational constant 6.67 into 10 to the power of -11. Mass of hydrogen they mentioned in the question 1.6 roughly into 10 to the power of -27. So there is one more 1.6 into 10 to the power of -27 divided by d square. So let us divide. Second, this is second, this is first. Before you write second, you simplify further if possible. 6.67. Once again, this is roughly 1.6, 1.6, 2.56 into 10 to the power of, let us say this is -1, -11, -27 is -38, -38 with 10 to the power of -27 divided by d square. So otherwise this is 50, 65, yeah, d square. So therefore let us divide FG and FE. So FG is 6.67 into 2.56 with the 10 to the power of -65 divided by d square. Then FE is also 9 into 10 to the power of 9. 9 into 10, 9 into, okay, -9 is cancelled. 2.56 with the 10 to the power of -29. So therefore by d square. So these two get cancelled once again. Now -65, if you take this up. So 6.67 with 2.56 10 to the power of -65 divided by, this is 9 into 2.56 with 10 to the power of -29. So therefore this get cancelled. So definitely fraction is 6/9 is less than 1. And there is here 65 minus 29. Because minus negative power both are having. This is going to be 6. This is 36 minus 36. You'll get, but since 6 by 9 is less than 1, so therefore altogether you'll get less than 1. So therefore increasing, making 37. Suppose roughly 60 if you take 9 sevens, 9 8, otherwise 9 6. So therefore 0.6 roughly you'll get. If you want to make, this is initially this is 36 only, but if you want to make higher number, so therefore 6 into 10 to the power of minus 37. So second option is correct. Moving to the next question. This is given in 18. An electron falls from rest through a vertical distance h in a uniform and a vertically upward directed electric field. So this is upward directed electric field means what? Somewhere here positive, somewhere here negative. So this is field direction. Now electron is released. The direction of the electric field is now reversed, keeping the magnitude is same. A proton is allowed. So direction of electric field reverse means now positive polarity of the field upwards, negative downwards. Now proton is released. Charge plus, yeah. Allowed to fall freely through the same vertical distance h. The time of fall of the electron. So remember, electron and proton will have numerically charged the same. So only the criteria is mass is the criteria. But before that, make use of S equal to ut plus half at square. So this acceleration, whatever the acceleration both proton and electron getting, that is due to electric field. So let us say electrical force is equal to ma. Formula of electrical force in association with the field line charge EQ with ma. So A is equal to EQ by M. Now this is going to be H. Falling down is negative. So therefore half. This is going to be EQ by M with T square. So therefore here field the same, charge the same, and H same. So T square by M is equal to constant. So, for example, if you take T electron square by mass of electron is equal to T proton square by mass of the proton. So, therefore, time is directly proportional to mass of the charged particle. So, therefore, if time is less, for which particle mass is less means what? Electron will have mass 9.1 into 10 to the power of minus 31, whereas proton will have mass 1.6 into 10 to the power of minus 27 kg. So therefore, mass of the electron is less. Looking at the power, mass of the electron is less. So the electron takes less time compared to proton. Now, question number 5. This is given in 18 also. A toy car with a charge Q moves on a frictionless horizontal plane surface under the influence of a uniform electric field capital E. Due to the force QE, its velocity increases from 0 to 6 meters per second in 1 second duration. At that instant, the direction of the field is reversed. Car continues to move for 2 more seconds under the influence of this field. So we need to find out average velocity and average speed of the car between 0 to 2 seconds. So first, when before the field is reversed, so let us say within 1 second duration, it has 6 meters per second. So let us try to find out acceleration when it is moving through uniform electric field. So acceleration is equal to V by T. So I assume that starting from rest, so therefore V is 6. Time is also 1 second duration. This will be 6 meters per second square. Now field direction earlier like this minus 2. Now field direction is reversed. So field direction is reversed. After the direction of the field is reversed, it is traveling 2 more seconds. So therefore, acceleration remain continue but with minus 6. So let us make use. The 6 will continue. So therefore, making use of what is the further distance. Even you can also find out distance traveled within 1 second. So starting from this, if you take ut plus half at square, then starting from this means this quantity does not exist. S is equal to half into A is 6. time is 1 second only, so there will be 3 meters it travels in first second. Now, after the reversal of the field direction, so let us try to find out u square by this is going to be 2e. So this u will continue, but acceleration is negative. Finally, maybe coming to rest. Yeah. So u is once again 6 square. So this is going to be 36 divided by a is retardation now. So minus 6. This is going to be 12. This is going to be 3. Yeah. Always we can separately find out the distance traveled between this is 0 to 1. Now let us try to find out 1 second to 2 seconds. So S is equal to ut plus half at square. So this is going to be, it will continue to have 1 second gap, but field direction is reverse. Half, this is 6, this is 1 second gap. So therefore, this is going to be 3 once again. So 6 minus 3 is 3. Now, last, so between 2 to 3 seconds. So assume that after 3 seconds, it is coming to rest. S is equal to half at square. So this is going to be negative, acceleration is negative, half into, this is minus 6 with t is again 1 second, 2 to 3 seconds gap. So therefore, this is minus. Now, what is the total distance? So here 3 meters, here plus 3 meters, here minus 3 meters. So therefore, so the total distance and total displacement. So therefore, distance, we require distance for average speed, 3 plus 3 plus 3, no subtraction. So it is 9 meters. So therefore, V average, so average speed is equal to total distance by total time. So total distance is 9 meters. Total time is 3 seconds. So this will be 3 meters per second. Speed is 3 meters per second. Now coming to velocity. So displacement is 3 plus 3 minus 3. So these two get cancelled. So it will be 3 meters. Now average velocity is displacement by time. Therefore 3 meters by 3 seconds. So it will be 1 meters per second. So average velocity is 1 meter per second and average speed is 3 meters per second. So second option is correct. Moving to the next question. 2 point charges A and B having charges plus Q and minus Q. So let us say these are the 2 point charges. This is plus Q and this is minus Q. Separate are placed at a certain distance apart, and force of attraction, because both are opposite charges, maybe attraction F in between them when they are separated by distance F. Yeah, this is D. If 25% of charge of A is transferred to B, so 25% means, so there is a removal here. So you can call QA is equal to Q minus 25% Q by 100. And it is added to minus Q. So therefore, minus Q plus. So first, this is 25Q by 100. So therefore, this is 75Q by 100. Then here, this is going to be again 75. 75, that is negative, 75Q by 100. So you call this is QB dash, new charge. This is QA dash. Earlier, QA is Q only. QB is Q only. Now the new charges, new forces, F is equal to K into QA, QB divided by D square. Now new charge, F dash you call it as K into QA dash into QB dash divided by D square. So therefore D square cancel, KK cancel. So QA by QB, QA into QB, QA is 75%. Otherwise you can write 3 by 4. 25 3 is a 25 4. 3Q by 3QA by 4 into, even this one also, QB dash also, 3 by 4 QB. So therefore QB cancel, QA cancel. So it will be 16. 16 by 9. So therefore F dash will be equal to 9 by 16 F. So third option is correct. Moving to question number 7. This is given in 19. Hollow metal sphere. So this is hollow metal sphere means what? You don't have any charges inside up to at least radius. Radius R uniformly charged. The electric field due to sphere at a distance R from the center. So therefore, there are some points here. Inside, anywhere inside, there are no charges. Only charges are on the outer sphere, outer surface of the sphere. So therefore, electric field, as and when you don't have any charge when it is taken in the Gaussian surface, you don't have any charge. So therefore, field will be 0. So less than R, distance less than equal to radius of the sphere. So field does not exist. You can construct Gaussian surface, but the Gaussian surface does not include any charge. So therefore, field will be 0 inside. Then decreases. So once field started from the outer surface of the sphere, so it will be 1 by 4 pi epsilon naught q by r square. So therefore, E and R are inversely proportional. So as distance increases from the outer surface, field decreases. The third option is correct. Moving to the next question. Two parallel infinite line charges with the linear charge densities. First one is plus lambda coulomb per meter. Second is minus lambda coulomb per meter. Are placed at a distance 2r in phase space. Let us say this is the infinite line charge with the positive lambda. This is another infinite line charge with the linear charge density minus lambda. These two are separated by a distance of 2r. What is the electric field midpoint, midway between the two line charges? So here this may be R from any infinite line. So this is A, this is B. So get back the formula for infinite line of charge. It is lambda by 2 pi epsilon naught R. Now suppose field you consider, if you consider field due to positive charge is away from, whereas field due to negative charge is towards. So these fields get added. So E due to positive lambda plus E due to negative lambda, this is equal to E net, because field is a vector quantity, again making use of parallelogram. So it is going to be lambda by 2 pi epsilon naught R, because you are looking for, this is the distance. So this R is the distance, plus lambda by 2 pi epsilon naught R. So they get added, 2 lambda by 2 pi epsilon naught R, and 2 and 2 get cancelled. So the final answer is lambda by pi epsilon naught R. So last option is correct. Moving to the next question. A spherical conductor of radius 10 centimeters has a charge of 3.2 into 10 to the power of minus 7 distributed uniformly. What is the magnitude of electric field at a point 15 centimeters from the center of the sphere? Directly write the formula. This is question number 9. Intensity of electric field due to a point charge. So 1 by 4 pi epsilon naught 2 by r square. So r is 15 centimeters from the center of the sphere. So this is 9 into 10 to the power of 9. Charge is 3.2 into 10 to the power of minus 7. 3.2 into 10 to the power of minus 7. R is in centimeters, so 15 square, so 225 with the 10 to the power of minus 4. So therefore, this is 25 times. Then this is 2 times. So it will be anyhow 10 to the power of minus 6 with the 3.2 by 25. Therefore, roughly you make it, this is 32 minus 1. This will be plus 6. So this is 5 you will get. This minus 1 is 10 to the power of 5 you will get. So 32 by 25 with 10 to the power of 5. So you can further simplify almost 1 time. 7 left, 25 2s are. 50, 200, it will be 8. So therefore 1.28 into 10 to the power of 5 Newton per coulomb. Field is measured in Newton per coulomb. So moving to question number 10. two charges is given in 22. 2 point charges minus q, here minus q, here plus q, are placed at a distance L. I think diagram is given in the question for this question, shown in the figure. Magnitude of the electric field at a distance r. So here this is the diagram. So how will you mark r means? So from the center to a point. So you might know the formula. Field intensity at a distance r from the center along the axial line of the dipole. So E is equal to E axial, you call it as. E axial equal to 1 by 4 pi epsilon naught. First you will get 2p into d. Okay, here they mentioned r. Better you write down this is r. Then you will get a L square minus r square whole square. In case if it is a short dipole, so you can ignore. Yeah, this is going to be d square minus L square. So r square minus L square. That's in the formula you'll get if you take d. So this is r square minus L square whole square. So if L is ignored, compare. So for the case of short dipole, L can be ignored. So you'll get 1 by 4 pi epsilon naught 2p by L is ignored means r to the power of 4. Therefore, it is formula E axial proportional to 1 by r cube. So last option is correct. So once again, there is a question based on the comparison of the electrostatic force and gravitational force. The ratio of Coulomb electrostatic force to the gravitational force between electron and proton at a distance is, so the ratio given, electrostatic force to gravitational force is 2.4 into 10 to the power of minus 39. The ratio proportionality constant is K is equal to 1 by 4 pi epsilon naught to the gravitational constant G nearly. Yeah, so get back the formula. Electrostatic force is 1 by 4 pi epsilon naught. Then electron and proton. So charges of electron is 1.6 into 10 to the power of minus 19. Then even charge of the proton is also 1.6 into 10 to the power of minus 19. This is divided by d square divided by fg. Then g is there will be g here. G is 6.67 into 10 to the power of minus 19. Then this is mass of the proton and electron, so 9.1 into 10 to the power of minus 31. With the proton mass is 1.6 into 10 to the power of minus 27 divided by d square. So they are asking us to find out this particular value. So let us rewrite this one. This they have given 2.4 into 10 to the power of minus 39 is equal to 1 by 4 pi epsilon naught. We are looking for this. Or d square get cancelled. Is 1.6 into 10 to the power of minus 19 charge of the proton or electron. There is one more 19. It's 1.6 divided by 6.67 into 10 to the power of minus 11. This is not 19. Minus 11 with the 9.1 minus 31. And this is going to be minus 27. Yeah. This is minus 38. So minus 38. Then we will get this is okay. This is plus 39. Yeah. This is minus 38. Then there is 31 here. 31, 11. So 42. So there will be minus 3 here. Then this is going to be 27, 30. Yeah. Then all together 1.6, 1.6 you can cancel. There is one more 1.6 here. 1.6, 1.6 get cancelled. Then so 2.4 into 10 to the power of 39 is equal to 1.6 divided by 6.67 with the 9.1 and this is going to be minus 30, 10 to the power of. So therefore, this is almost 4 times. You can cancel this and this. So we missed one quantity here, and there is minus 42. This will be minus 4. So this will be minus 31. Yes. So therefore, roughly this is closer to 10. Yeah. Then next this is going to be 8, 39 plus 39 minus 31. So therefore, there is 1 by 4 by epsilon naught here. Therefore, 1 by 4 by epsilon naught is equal to 4 get multiplied with 2.4. This is not exactly 4, close to 4. 4 into 2.4. If you take 2.5, it will be 10. This will be 9.1 with 10 to the power of 8. So remember, when you do the numericals in electricity, we take 1 by 4 by epsilon naught as 10 to the power of 9. So, but how? What is the reason? 4 into 2.5 is 10. There is already 9.1. There is 8 10 to the power of. So 110 get added to 9. This is the value of 1 by 4 by epsilon naught. So this is, make it 20 to the power of 9. 9 into 10 to the power of 9. So it is 9.1. Or roughly, you can make 10 to the power of 10. Yeah. So it is, you make it as 10 to the power of 10, not 10 to the power of 20. Students, in the next video, I'll continue explanation for the previous NEET questions from the chapter Potential and Capacitance. Thank you very much for watching my video, but don't forget to share with your friends and subscribe.